Hi kids, you're back. You must have loved the first video. That makes me really happy. Well, in this quick video, we want to look at an increasing, that's y is equal to 3 to the power of x, increasing exponential function and its graph, and a decreasing exponential function and its graph. Y is equal to 1/2 to the power of x. So I'll make a table of values, plot those points, and then look at the graph. So we'll make it nice and short, and let's see what happens here. So here we go. So here's y is equal to 3 to the power of x. If x is equal to 0, that means I'll have 3 to the power of 0. But 3 to the power of 0, of course, is 1, right? So at 0, we get 1. That's our y-intercept. When x is equal to 1, we get 3 to the power of 1. Well, 3 to the power of 1 is 3. So when x is 1, 1, 2, 3. When x is 2, 3 to the power of 2, 3 squared. That's 9. Oh, I do recognize that, wow, these values of y are increasing with a factor of 3. It turns out this number 3 is called a growth factor. Right? So there is a common ratio, we say, between consecutive y values. 9 divided by 3 is 3. 3 divided by 1 is 3. In fact, if I were to guess what the next value of y would be, I'd say 27. So if x was 3, y would be 27. 9 times 3 is 27. But I won't have room for it since exponential functions are fast-growing functions. We know that. There's no room for it, so we'll stop at x is equal to 2. So when x is equal to 2, we get 9. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. As you can see, there's the exponential curve. Now on the other side, when x is equal to -1, we get 3 to the power of -1. And if we do remember from our pre-algebra days or algebra 1 days, 3 to the power of -1 means 1 over 3 to the power of 1, which is 1/3. So at -1, we get 1/3, which is kind of hard to plot, but we'll do the best we can. At -2, we have 3 to the power of -2. Again, from our younger days, we know that's 1 over 3 squared. So 3 to the power of -2 is 1 over 3 squared. 1 over 3 squared is 1 over 9. That's really tiny. All right. And we remember from that last great video that as we go to the left, the curve gets closer and closer to 0, and it's quite evident that that's the case. So plot these, or excuse me, connect these the best I can. I get a nice curve where the left end behavior is 0 and the right end behavior is infinity. That's y is equal to 3 to the power of x. X-axis, y is equal to 0, is my horizontal asymptote. On we go to 1/2 to the power of x. We do remember from the other day, or from the other video, excuse me, that this graph will be same type of graph, except instead of going to infinity on the right side, in this case we'll go toward infinity on the left side. Okay, here we go. When x is 0, we have 1/2 to the power of 0, which is 1. So again, 0, 1, which is our y-intercept. When x is 1, we get 1/2 to the power of 1, but 1/2 to the power of 1 is just 1/2. So at 1, we get 1/2. When x is 2, we get 1/2 to the power of 2, but 1/2 to the power of 2 is 1/2 times 1/2. 1/2 times 1/2 is 1/4. So at 2 we get a quarter. And as you can see, as we go further to the right, the graph is going to get closer and closer to the x-axis, our horizontal asymptote. -1, 1/2 to the power of -1 means what? Well, this -1 flips over the 1/2. So I'll end up with a 2. That's the job of -1. In fact, that's the job of the negative sign. It flips the fraction over, and I'll get 2 to the power of 1. So at -1, we get 2. At -2, we have 1/2 to the power of -2. Again, what does that mean? Well, the negative sign flips this over, makes a 2, then we have 2 squared, which is 4. So at -2, we get 4. Right, so again, let's make sure we remember the job of a negative exponent is to flip your base over, give you the reciprocal of the base you're dealing with, and then use the power to, raise it to whatever power you need to raise it to. So again, connecting these, we get this nice curve, nice exponential curve, where the right end behavior is 0 and the left end behavior is positive infinity. Next video, we'll take an exponential function and we'll have it with some transformations. We'll shift it, or we'll reflect, or we'll stretch and compress in the vertical or horizontal directions. Until then, goodbye.